to have the next topic, nutrition and optimal neurodevelopment in infants and young children, evidence-based insights, and it's going to be taken by Professor Ikeoluwa Lagunju. May you be upstanding, ma'am. Professor Ikeoluwa Lagunju is a professor of pediatrics at the College of Medicine, University of Ibadan, and consultant pediatric neurologist at the University College, Ibadan. She received her undergraduate medical training in UCH Ibadan. She graduated in 1988 as the top student in her class, winning several awards and prizes. It's a good place to give an applause. Professor Lagunju later undertook her residency training in UCH. She's a fellow of the Nigerian Postgraduate Medical College of Nigeria, a fellow of the West African College of Physicians, and a fellow of the Royal College of Pediatrics and Child Health, United Kingdom. She's a recipient of several international awards. She received the prestigious Association of Commonwealth University Fulton Fellowship in 2005, the Bernard Dizot Award of the Child Neurology Society, USA, in 2008, and the Bruce Schubberg Award of the American Academy of Neurology in 2011. She received training on electrophysiology in the Cleveland Clinic, Ohio, and the Addenbrooke's Hospital, UK. And because of that, after that, she established the first routine transcranial Doppler ultrasound clinic, and she has pioneered the work on primary stroke prevention in sickle cell disease, which is quite prevalent in our environment. Professor Lagunju's research interests focus on early childhood development, childhood epilepsy, developmental disabilities, and stroke in sickle cell disease. She has authored a textbook, 8 chapters in books, and more than 90 journal articles. And she is the immediate past head of Department of Pediatrics, College of Medicine, University of Ibadan, and the immediate past president of the Childhood Neurology Society of Nigeria. Please put your hands together for Prof. You're welcome, ma'am.
Good afternoon, everyone. The chair, our teacher, and all the distinguished panelists, distinguished audience, my colleagues in the audience, everyone, good afternoon. And I'd like to thank FrieslandCampina for this opportunity to be here today to share experience on the link between nutrition and early child development. I want to especially thank Ngozi for her warm hospitality. She's worked so hard. Thank you very much. So in the next 20 minutes, I'll be talking about nutrition and optimal neurodevelopment in infants and young children, evidence-based insights. So this slide shows the overview. I'll tell you a few things about early brain development, but I won't make any attempt to make you embryologists because you all just walk out on me. So I'll talk about stages of brain development so that we can put things in perspective. And then in rounding off, I'll bring a link between nutritional factors and what they do with regards to brain development. So it's important that we know that human brain development is a protracted process that begins in the 3rd gestational week. So the brain begins to grow even before the woman realizes that she's pregnant. So by the time she knows that she's pregnant, I've missed my period, I go for an ultrasound, some critical events would have happened that can mar or, otherwise the situation of the baby. And those processes involved in early brain development range from molecular events of gene expression to environmental input. And right at the center of this is the quality of nutrition. And when either of those is disrupted, then you can have serious consequences in how the baby's brain turns out to be. Between the time a woman conceives and the age of 3 years, the brain undergoes an impressive amount of change and grows at an amazing rate. And by the time a baby is born, almost all the neurons that the baby will need are present. So then what goes on after birth? After birth, brain growth is mainly by division and multiplication of the glial cells, which are the supporting cells. The key thing after birth are the synaptic connections, the wiring of the brain, and that's why what we want babies to do, there are things we make them do repeatedly so that they learn and they don't unlearn those things. This slide just shows you, the key things that happen in brain development, the major events. So you have the very early part that we call the embryonic period, induction of the neural plate, formation of the neural tube. And once the neural tube is formed, you find this sophisticated division along several axes. And at the end of that, what do you see? You see that there is segmentation, so it's defined what each part will become ultimately. So we talk about segmentation, specification, and regionalization. And then you also have neuronal proliferation. These neurons, the brain cells, are produced in billions. And initially when they are produced, they are alike. Thereafter, they form into special types, different types, the one that will be for hearing, the one that will be for vision, the one that will be for walking, movement, different things. And then so they become the specific types. And the last thing they do is to move from where they are produced to where they will settle down and work. I'm sure people came to work in Lagos from different parts. I don't work in Lagos, so I haven't migrated to Lagos. But many people, it's just the same principle. So these cells will live where they are made, and they migrate to where they will work. They settle in there to their circuits, and then they form synapses. That's what we call synaptogenesis, and then myelination, so that these nerves are coated with the special protein that makes the nerves to work very efficiently. So again, to summarize this, you have, so the key things that we need to remember: neuronal proliferation, differentiation, migration, the formation of synapses, and then the myelination. Again, you see that this timeline, this slide is just to show that this actually begins as soon as the baby is born. So you see the part in, do I have the pointer? Yes. So about there, that phase is ever before the baby is born. So you see that a lot happens before the baby is born, the migration and all the other things. And then after the baby is born, this continue, particularly the myelination. And then you have other things and speech, things that the child needs to move, to talk, to acquire language and all of that. And the pathways for language, speech, and higher cognitive functions rapidly develop during infancy and the toddler period. And I think this shows it a little more clearly, that we see that babies begin to move right from when they are in utero. So you see the motor development. But as soon as the baby comes out, then all the things that are needed to develop speech, vision, even emotions. Baby begins to smile, knows mommy different from other people, and then much later, 1 plus to 2, they begin to make friends. They value social relationships. All these are connected. So the brain, it happens, you can't see it, but you can see the effect of those changes by the attributes that the children develop. So for brain development, time is of the essence. And when a baby is born, the brain is about 60% of its adult size. By the end of the first year, it's grown up to 72%. And by the age of 5 years, it's about 90% of the adult size. And during this period, in the first 5 years, the brain undergoes rapid structural growth as well as functional maturation. And there is increasing evidence, to show that nutrition in early childhood has a significant impact on neurodevelopment across the lifespan. So, what is the connection between nutritional factors and brain development? One key thing we need to know as people take care of children is the fact that optimizing nutrition during fetal and early postnatal life is a golden opportunity, is a window of opportunity which you want to optimize to impact neurodevelopment and brain function across the lifespan. It's a window. That window never remains open, does not remain open indefinitely. So, fetal life, early childhood, and these nutrients and growth factors regulate early postnatal brain development. And early life nutritional deficits can affect brain function across the lifespan. Because once the window of opportunity is missed, then it becomes very difficult to recover this. The growing brain requires timely and high-quality nutrition, and the early childhood is a sensitive period for nutritive action. We talk about the sensitive period, and we talk about, deficiencies during this stage may cause profound and irreversible damage. And it's so interesting, a lot of what I describe the anatomical changes in talking about brain development, but the effect of nutrients are not limited to how the brain really grows in size, in anatomy, but the way it functions. So we talk about neurochemistry and neurophysiology, so for the brain to perform. So that's why you see that it's not necessary that this person's head is big, then the person will be very brilliant. It's never like that. So it's not just the anatomy. We talk about the neurochemistry and neurophysiology. And all nutrients are important for neuronal cell growth and development, but some appear to have greater effects during early development. So our focus today is DHA, docosahexaenoic acid, and it's been shown from studies that DHA is so crucial at every stage involved in brain development. So it's critical to support the 4 key neurodevelopmental processes. DHA is important for neuronal proliferation. It's important in formation of synaptic connections. It's important for pruning, because what does pruning mean? The connections that you don't use frequently, they are lost, so that the ones that the child needs and are used more frequently, they can bloom and become very solid and irreversibly connected. DHA is very crucial for the growth of the axons and the dendrites, as well as myelination. And myelination has been shown to be the key thing underlying the effectiveness of brain function. So, is DHA the key nutrient for supporting brain development in children? Is it? Yes, thank you. It is. And what is this DHA? Why is so much fuss about this DHA? It's an omega-3 fatty acid, and it's so important because it's a primary structural component of the human brain, the retina, and the nerve tissue. DHA is, for the young infant, for the newborn, is obtained directly from the breast milk, and that's why it's so crucial that babies get exclusively breastfed in the first 6 months of life, and they continue with breastfeeding till they are age 2 years. DHA is, while the baby is in utero, or in the mother's womb, DHA is obtained or is taken from the mother across the placenta. And mothers get the DHA directly, when they take fatty fish, fish oil, algae, and I'll talk about the sources in a minute. And it can also be synthesized within the body from alpha-linoleic acid. DHA is the most abundant long-chain polyunsaturated fatty acid in the brain, and it supports major neurodevelopmental functions. It's the main structural component of nerve cells. It's present in large quantities in the brain, and during growth spurts it's been shown to increase about 30 times. DHA helps to maintain neuroplasticity in the brain. And what does that mean? Neuroplasticity is the ability of the brain to make new connections and to recover from injury, so that somebody who has an injury is not talking if after a few days, oh, the child is now speaking. The brain makes new connections to be able to overcome those setbacks, and it protects against loss of scaffolding proteins and oxidation degradation lipids. So it's essential for the development of cognition. DHA makes up 40% of the polyunsaturated fatty acids in the brain, and 60% of the polyunsaturated fatty acids in the retina, and 50% of neuronal plasma membrane is DHA. So DHA is a key building block for infant brain and eyesight development. The retina is rich in DHA, and vision is critical to normal child development. So a child's brain will not develop normally when the vision is compromised, because a lot of what the baby needs to develop comes through the visual input. So vision is critical. And this slide is just to show that DHA accumulates in the brain beginning in utero, through toddlerhood, and indeed till adolescence and adulthood. So it is really very important. What are the DHA requirements and what are the sources through which infants and young children can get DHA? Said earlier, number one, as soon as the baby is born, exclusive breastfeeding is the right answer. Every baby gets that. A baby that is exclusively breastfed is sure to get sufficient DHA requirements. But from the age of 6 months, the baby needs to go on complementary diet, and so diverse diet becomes important. Once the child is eating solids, it's advisable to provide them with a diverse diet to ensure adequate nutrition. And which food sources are rich in DHA? Fatty fish, such as salmon, sardines, mackerel, tuna, egg yolk are good sources of DHA. But do our children get these sources? And if you look to the right side of this slide, you'll see, like a typical diet for a Nigerian child or a Ghanaian child, and you see that if we're not intentional, we'll feed these children, but we won't feed them with what they need. So there's an urgent need to bridge the dietary gap of DHA in young children, because when you give the bread or cereal, you serve the egg, you give a bowl of rice, egg just once a day, and then a bowl of vegetables. You give the chicken in small amounts, and then you give the glass of, regular milk. There's a chance that the child will not get the required amount of DHA. And DHA deficiency during gestation, infancy, and early childhood may be associated with later life neurological and cognitive challenges. And examples will include poor visual acuity, attention deficit, hyperactivity disorder, autism spectrum disorder, and a number of developmental disorders. And so we must ensure that they get enough so that we can reduce the huge burden of neurodevelopmental disorders in children in our setting. So there's been a lot of evidence to show that when there's enough or sufficient DHA in the diet, it makes a huge difference. And this is from some of the published work that showed that babies who had their diet supplemented with DHA had higher mental developmental index scores. Another study showed that they had more time engaged in active stimulus processing, and so they learned better and they paid attention better. Another study showed that they had improved visual acuity, and I just talked about the fact that vision is critical to normal development. And so when we look at the long-term neurocognitive deficits of DHA supplementation in infancy, the gains are actually all through the lifespan, you would say. Between the age of 3 to 5 years, it's been shown to improve their vocabulary. Between 5 to 7 years, they found that those children did a lot better and had higher scores on the WIPS scale. And then at 9 years, they had greater brain activation, so they did a lot better. So, and then interestingly, beyond neurodevelopment, DHA has been shown to reduce the allergic, manifestations in children who had good diet, and so lower incidence of bronchiolitis, lower incidence of nasal congestion, and allergy to specific pollens. So DHA, better learning, enhanced memory, improved behavior, and superior executive functioning. The other important brain nutrients, even though they are not really in focus today, but it's worth mentioning that iron will be very important, taurine, choline, selenium. They all have their very important roles to play, and that's why we keep hammering on the fact that the diet needs to be balanced. So it's not like DHA and then no other things. So then, as a roundup, what are the take-home messages? The first few years of life are characterized by rapid brain growth and neural development. Nutrition in early childhood has a significant impact on neurodevelopment across the lifespan. Breast milk remains the best source of nutrition for babies in the first 6 months of life, and we all must join our hands together to ensure that our babies are exclusively breastfed and mothers keep breastfeeding till the babies are 2 years. All nutrients are important for neuronal cell growth and development, but certain nutrients like DHA and the other one, iron, choline, selenium, appear to have greater effects during early development. DHA is the most abundant long-chain polyunsaturated fatty acid in the brain as well as in the retina, and it supports major developmental functions. So as I conclude, please always remember and keep encouraging everyone around and keep singing the song that breast milk is considered, and it is, the ideal source of nutrition for the optimal development of the infant. Thank you very much.